This video lesson is going to be about direct variation. Direct variation simply means that y varies directly with x. And this is the equation that we use. It's called y equals kx, where k is actually the constant rate of change. So we might just draw an arrow here, where again, k is the constant rate of change. So let's take a look at some examples and you understand what I mean. So here we have a couple of examples. This first one says y equals 3x. And then we have another one that says y equals negative 2x. So I want to show you in this equation how y varies directly with x. So we're going to input some values for x. Well, let's go ahead and start by filling out this table. So let's say we have x and y table here. Let's say we plug in a 1. Well, if x is 1, then we just multiply 3 times 1 and we get 3. What if x was 2? We would multiply 3 times 2 and we would get 6. Let's say we multiplied, let's say our x was 6, and we would say 3 times 6 is 18. And then finally, let's say we had a 12. 12 times 3 is 36. All right, so what I want you to see here is this table, and to kind of identify a pattern, let's look at the change in x as well as the change in y. So if you're going from a 1 to 2, you're going to multiply times 2. And if you're going from 3 to 6, you're also multiplying times 2. All right, what if we go from 2 to 6? We multiply times 3. So if we multiply times 3 with the x's, then is it the same with the y's? Well, yes, if you go from 6 to 18, you're multiplying times 3. So you can see here that the y varies directly with the x. As we change the x, so we're changing the y. Now, another way to see it is simply to look at the output of y. If you go from a 1 to a 3, you've multiplied times 3. 2 to 6, you've multiplied times 3. 6 to 18, you've multiplied times 3, and so on. That's a constant rate of change. We are always multiplying the x times 3 to get our output y. And that's what the equation says. Y equals 3x, where the constant rate of change is the 3. All right, let's take a look at this one. This is y equals negative 2x. Again, we have our x and y. Let's just, if we plug in a 1, we multiply 1 times negative 2, which would be negative 2. Let's say we plug in a 2. Negative 2 times 2 is negative 4. And then we could just keep going. Let's say we do 3, that would be negative 6, and 4 would be negative 8. So had you just been given this table and you were to be asked, kind of to see if it was a direct variation, then you could look to see if the y varies directly with x. That would mean that you would have to have a constant rate of change for each one of these. And of course, you can see in this one, the x is being multiplied times negative 2 and each one of these times -2 times -2. They're all being multiplied times -2, which was, of course, the original equation, okay? So that is what an equation looks like for direct variation. Something to think about when you have a direct variation, and it's y equals kx, where you have a constant rate of change. Again, just another example. Let's say we have y equals 2x, and you make a real quick table. If you plug in a 1, you get a 2. If you plug in a 2, you get a 4. If you plug in a 3, then you get a 6, okay? So if we go over here to our graph, and we were to graph that, for the first one, we go over 1 and up 2. Over 1 and up 2. For the next one, we would go over 2 and up 4, and so on. Well, what if we had plugged in a 0 over here? What would we get? Well, 2 times 0 is 0. So something that you need to know with direct variation is that the graph will always go through the origin. When you have an equation that is direct variation, or a function that is direct variation, y equals kx, then you will always have the graph going through 0, 0. This is called the y-intercept, okay? All right, now let's take a look at this additional example. So here's an equation. It says 2x plus 3y equals 0. And what we want to determine is this direct variation? So it's not given to us real simple as like y equals 2x or something, but it's given us as 2x plus 3y equals 0, okay? So if we want to determine if this is direct variation, then we would need to determine, does it say y equals kx, all right? Well, let's work with this equation and see if we can get it into this format over here, okay? So simply what we'll do here is we will subtract 2x from both sides. So now our equation says 3y equals -2x plus 0. Well, if it's plus 0, then we really could just get rid of the 0. So the 0 goes away. Now it says y equals -2x, and if we wanted to solve it for just y, then we will divide both sides by 3. And now it says y equals -2/3 x. And that is in the form of y equals kx. So this equation is direct. This equation then would be direct variation. Again, if we made a quick table of x and y, we could plug in a 1 for x, and our answer would be negative, or our output would be -2/3, our y. If we plugged in a 2, then we would actually have -4/3. And then if we plugged in a 3, we would actually get -2. All right. So again, you can see over here the pattern where we have this constant rate of change. If you have a 1 and you scale it up to 2, you multiply times 2. You do the same thing with the y over here, times 2, and you get -4/3. That's because this is a constant rate of change. It's a direct variation.